Welcome to IS Academy. Today we'll understand what is the gear ratio. So let's start. Okay, so there are basic three formulas for calculating the gear ratio. One is for the diameter, one is for the teeth, and one is for the speed. So always remember when you are taking into consideration these two parameters, that is the diameter and teeth. So our gear ratio formula is the output upon input. Okay, so basically the output upon input, that is the output gear diameter divided by input gear diameter gives you gear ratio. Output gear teeth to the input gear teeth, it gives you your gear ratio. And when you are taking the gear ratio with the help of the speeds, that is the rpm. Okay, so the formula is inverse. You have to take into consideration input upon output. Okay, so this is the basic formula, and let's understand with the help of this the figure, there is one gear pair over here. So this is the gear number one and the gear number two. So always remember this gear is also known as the driving gear. Okay, so the smaller one gear, that is the input gear, is known as the driving gear, and the bigger one gear, it is known as a driven gear. Okay, so what is the driving gear? When the gear is connected to your machine engine or any power sources, so that time it is known as a driving gear or the input gear. And the gear which is connected to your driving gear, it is known as a driven gear. Okay, so driven gear is always connected to the driving gear, so it's a input and output. Like these terms we are considering for easy to understand. Okay, one more thing is very important. Like let's assume one example, like your output gear teeth is 100, that is this is the larger one gear, there is 100 teeth. And for the input gear there is a, let's assume there is a 10 teeth. Okay, so our gear ratio comes like the 10. So when your gear ratio is greater than 0, that is what the greater than 0 means, sorry, greater than 1, 1.5, 2, or whatever it is your gear ratio is coming. Okay, so that time the it's known as a reduction ratio. Okay, it's known as a reduction ratio, or it's a gear ratio, it's known as a reduction gear ratio. Not for the one, but if it is greater than 1. Okay, when it's smaller than 1, that is a point 0.5, point 0.2, anything. Okay, that is a 0 point terms. Okay, that time it's known as a incremental gear ratio. This is reduction gear ratio, this is the incremental gear ratio. So how you are going to understand? Okay, so this gear ratio is written as a 10 has to 1. So meaning of this 10 has to 1, that is a 10 revolution. For each 10 revolution of input gear, there is a 1 revolution of your output gear. Means the smaller gear when rotates the 10 times, this gears. Okay, the smaller gear is rotated the 10 times, the bigger one gear rotates only 1 times. So there is a reduction of the RPM. You can see there is a 10 RPM and it's here is a 1 RPM. So there is a reduction. So it's known as a reduction. Okay, what if there is a zero point 0.5 has to 1 gear ratio? It means when input gear rotates zero point 0.5 times, okay, the output gear rotate 1 times. Okay, so when it rotates the full turn, that is a 1 turn, it rotates the 2 times. Okay, so you are get to know that your output gear rotates the more RPM, that is a 2 RPM. Okay, and it's 1 RPM. So that time you are getting the incremental gear ratio. Okay, so that thing is very important just to understand. Like when you see there is a 2 gear ratio, it means there is a reduction gear ratio. When you see the point 2, then there is a incremental gear ratio. Okay, just for understanding I have shared this. Okay, let's take one example to understand uh, the gear ratio. Okay, here we have taken the three parameter, that is the teeth we have taken, diameter is taken, and we have to calculate the rpm of the our driven gear. So this is the gear number one, this is the gear number two, that is the driving gear and the driven gear. Okay, let's start with the gear ratio. With the gear ratio we can write down the formula for the teeth. Okay, that is the output teeth, that is output gear teeth T2. I'm considering T2 is the output. Okay, T1 is the input. So what is the T2? It's 100 divided by 20, it gives you 5. Okay, for the gear ratio in terms of the diameter, that is the output gear diameter, that is a D2 divided by D1. Okay, let's understand this easily. Okay, so D2 is a 150 and D1 is a 30 and this is a 5. So you can see the gear ratio is the same. Okay, so we can calculate the RPM. So for the RPM we have formula S1, that is the RPM, the speed of the gear one, because input we have taken first. Okay, then the output, that is S2. What is the S1? S1 is a 200 divided by S2, we have to calculate. And what is the gear ratio? Gear ratio is 5, as we calculated with the help of the teeth and diameter. Whatever it is, there is only one parameter. If we have, then we can calculate the another one parameter. Okay, so S2 we can written like this: 200 divided by 5, it gives us a 40. So what is a unit for S2? This is a 40 rpm. Okay, and always remember, for the gear ratio there is a no unit, because teeth upon teeth, diameter upon diameter, there is a no unit, it's just a number. Okay, the gear ratio is just a number. So this type of the gear ratio we have understood. Okay, if you have any queries or any questions regarding the gear ratio, you can comment